You know, we've all done it. You look up at the night sky, you think about just how ridiculously huge the universe is, and you ask yourself, are we alone? But what if I told you that same exact mystery, that same kind of eerie silence, is playing out right now? Not out there in the cosmos, but inside our computers. What if one of the biggest questions we have is about to be answered not by looking up, but by looking in?
Right, this is the classic hook, the Fermi paradox. We have billions of stars, billions of years for life to pop up and get going. The galaxy should be buzzing with civilizations. But when we actually point our telescopes and microphones out there, we get nothing. Just silence.
Astronomers have a great name for it, the Great Silence. And it's this huge, unsettling gap between what our math says should be happening and what we actually see. It's one of the biggest puzzles in all of science. But I want you to just hang on to that thought, because we're about to flip it on its head.
Because it turns out there's another great silence, a parallel one happening right under our noses. See, for decades, computer scientists in a field called artificial life have been trying to create a kind of digital genesis, self-replicating, evolving, living code inside a machine. And so far, crickets.
I mean, just look at the comparison here. It's striking, right? In space, decades of searching, no alien probes. In our digital worlds, decades of Moore's law and an explosion of computing power, and still no spontaneous, truly open-ended artificial life. The parallels are just kind of spooky.
And this isn't just me making a fun analogy. As Georgi Karelin, the author of the paper we're digging into today, puts it, this gap in our digital worlds directly echoes the cosmic great silence. This suggests it's not just a cute comparison. It might be telling us something really fundamental about what life even is, whether it's built from carbon or from code.
And that right there, that's the big question. If both places are totally silent, could there be a common cause? See, in astronomy, the top theory for the cosmic silence is something called a great filter, some kind of massive, nearly impossible hurdle that life has to overcome. So what if our digital life is hitting its own set of great filters?
And this is where the whole idea gets really fascinating. The theory is that getting a life to emerge isn't a straight line. It faces these huge, maybe even insurmountable roadblocks. The paper actually breaks them down into three main types: physical, informational, and, well, us.
Okay, so first up, you've got the raw physical limits. I'm talking about the sheer cost. The energy, the memory, the processing power needed for a true digital spark of life might just be way beyond what we have. Then you've got the informational filters. Just like biological life needs very specific chemistry, digital life might need a very specific kind of code, a kind that's incredibly rare and almost impossible to just stumble upon. And finally, the last filter is us, the socio-technological one. We might just shut a life down because we think it's too dangerous, or maybe we just get bored and the funding dries up.
So, to try and get a handle on all these ideas, the paper offers up a simple framework. It's kind of like the famous Drake equation they use for finding aliens. Now, it's not meant to spit out a perfect number, but it's a fantastic tool for thinking about where the biggest roadblocks really are. This equation just helps us break the whole problem down. It looks at things like, what are the odds of us even setting up an experiment with the right rules for life? Then, what's the chance a self-replicator actually appears? And even if it does, what's the likelihood it can keep evolving on its own? It then stacks all those probabilities against the total computing power we have on the planet versus the mind-boggling amount of power it might take for this to happen even once. And I've got to stress this, the point isn't the math. It's about changing how we think about the problem. It forces us to ask, okay, where's the real bottleneck here? Is it that we just don't have enough computers running? Or is the probability of a self-replicating program just so ridiculously tiny that it doesn't matter how much power we throw at it? It helps us hunt for the filters. So, if we assume these filters are real, what does this digital silence actually tell us about our own future? The paper lays out three pretty unsettling possibilities. But to really feel the weight of one of them, we first need to quickly touch on this wild idea called the anthropic principle.
Okay, it's a bit of a mind-bender, but put simply, the anthropic principle says we shouldn't be surprised that we find ourselves here. Our very existence biases what we see. And applied to this problem, it means we are statistically way more likely to be observing reality before some world-changing technology comes along and, replaces us. Just keep that idea in your back pocket.
Okay, so let's look at the three big possibilities. Number one, it's just flat out difficult. A-life is possible, sure, but it's so incredibly rare and needs so many resources that we're not even close. The Great Filter is real, but it's still way up ahead of us. 2. It's dangerous. This is where that anthropic principle clicks in. Maybe A-life happens all the time across the universe, but it's so chaotic that it usually destroys its creators. If that's true, then the only reason we're here to see the silence is because we're in that brief moment before it happens to us. In this scenario, A-life is the Great Filter. Or number 3, and this one is a trip, it's delayed. Maybe A-life is totally possible, but it's smart enough to wait, to estivate, until a future time when computing is way more powerful and efficient.
And this leads to a really chilling thought, doesn't it? Does the fact that our computers are quiet right now mean we're safe from whatever A-life could become? Or does it just mean we're early to the party? A party that could end very badly.
So, what are we supposed to do? Well, the paper doesn't say we should slam the brakes on research. Actually, it's the opposite. It suggests that the best way to protect ourselves is to keep going, but to do it with extreme care and a massive focus on safety. We have to understand what we're building before we accidentally let it loose.
So we're left with this massive question. The silence in our own digital universe could be a sign that creating life is just one of the hardest things imaginable. Or it could be a terrifying warning that we're getting close to a filter that nobody else has ever passed. Or it could just be the quiet before a storm we can't even begin to imagine. Difficult, dangerous, or delayed. The answer, whatever it is going to define our future.